To monitor voltage surges, a suitable meter is the Fluke 1777 Power Quality Analyzer. This advanced meter measures and logs voltage, current, power, and other electrical parameters. It has built-in memory that can store up to 1000 measurements, making it ideal for long-term monitoring. Firstly, verify surge presence. Install the Fluke 1777 meter and set it to record voltage fluctuations over the desired monitoring period. If the data shows frequent voltage spikes or dips, it confirms the presence of power surges. Secondly, determine the surge source. It could be utility cost surges. In this case, contact the utility company to report the issue and request an investigation. They can assess the power lines and make necessary adjustments. It could also be internal wiring issues. Hire a qualified electrician to inspect the home's electrical system for loose connections or faulty wiring that may be causing surges. It may also be external factors. Check for any nearby electrical equipment or appliances that may be generating surges when turned on or off. Thirdly, consider surge protection measures. Install surge protectors on all major appliances and electronic devices to absorb excess voltage and prevent damage. Consider installing a whole house surge suppressor at the electrical panel to protect the entire home from incoming surges. Use UPS, that is, an uninterruptible power supply, to provide backup power and surge protection for critical electronic devices. Fourthly, use ongoing monitoring. Once surge protection measures are in place, continue monitoring voltage fluctuations with the Fluke 1777 meter to ensure protection effectiveness. If new surges occur, repeat the troubleshooting steps to identify and address the underlying issue. Some additional tips include using high-quality surge protectors with a high Joule rating, which is a measure of surge energy absorption. Install surge protectors directly into wall outlets, not power strips or extension cords. Regularly inspect surge protectors and replace them when they reach their end of life. The Fluke 1777 is designed for capturing a comprehensive range of power quality disturbances. These include fast transients, also known as voltage spikes, which are very short-duration high-voltage events. It also captures intermittent and random voltage variations. Voltage sags, which are short-term decreases in voltage, and voltage swells, which are short-term increases in voltage. In addition to voltage disturbances, the meter also measures current disturbances, such as inrush current, which is the high initial current drawn by some devices when they are first turned on, and harmonic distortion, which is the presence of unwanted frequencies in the current waveform. The Fluke 1777 provides detailed data logging capabilities. It can record a large number of parameters simultaneously, such as voltage, current, frequency, power, harmonics, and transients. The logging interval can be adjusted to capture events over short or long periods, from seconds to weeks. The meter also includes event capture capabilities. It can automatically detect and record voltage spikes, swells, interruptions, and transients. This feature is useful for identifying the root cause of power quality problems. The Fluke 1777 can generate reports in various formats, including comma-separated values and portable document format. These reports can be used to document power quality problems and to track the effectiveness of mitigation measures. To use the Fluke 1777, first connect the meter to the electrical system that you want to monitor. This can be done by plugging the meter into a wall outlet or by connecting it to the electrical panel. Once the meter is connected, configure the logging parameters. This includes setting the logging interval, selecting the parameters to be logged, and setting the trigger levels for event capture. After the logging parameters are configured, start the meter. The meter will begin logging data according to the configured parameters. The data can be viewed on the meter's display or downloaded to a computer for further analysis. To analyze the data, use the Fluke Power Analyze software. This software allows you to view the data in various formats, such as graphs and tables. You can also use the software to generate reports. Here are some specific examples of how the Fluke 1777 can be used to solve power quality problems. For example, you can use it to identify the source of voltage sags. Voltage sags can cause equipment to malfunction or shut down. By logging voltage data with the Fluke 1777, you can identify the time of day when the voltage sags occur. This information can be used to identify the source of the voltage sags. For example, the voltage sags may be caused by a large motor starting up. You can also use it to troubleshoot harmonic distortion. Harmonic distortion can cause equipment to overheat and fail. By measuring harmonic distortion with the Fluke 1777, you can identify the source of the harmonic distortion. For example, the harmonic distortion may be caused by a nonlinear load, such as a variable frequency drive. And also, you can use it to evaluate the effectiveness of surge protection. Surge protectors are designed to protect equipment from voltage spikes. By logging voltage data with the Fluke 1777, you can verify that the surge protectors are working properly. You can also use the data to determine the maximum voltage that the surge protectors are able to suppress. When you are choosing a surge protector, consider the following factors. Firstly, the surge current capacity. This is the maximum amount of current that the surge protector can handle. Choose a surge protector with a surge current capacity that is adequate for the equipment that you are protecting. Secondly, the voltage protection rating. This is the maximum voltage that the surge protector will allow to pass through to the protected equipment. Choose a surge protector with a voltage protection rating that is appropriate for the equipment that you are protecting. Thirdly, the let-through voltage. This is the actual voltage that the surge protector allows to pass through to the protected equipment during a surge event. A low let-through voltage indicates better protection. Fourthly, the response time. This is the time it takes for the surge protector to begin clamping the voltage during a surge event. A faster response time indicates better protection. Fifthly, the joule rating. This is a measure of the amount of energy that the surge protector can absorb before it fails. A high joule rating indicates a longer lifespan. Sixthly, the number of outlets. Choose a surge protector with enough outlets to accommodate all of the equipment that you want to protect. Seventhly, the indicator lights. Some surge protectors have indicator lights that show whether the surge protector is working properly. These lights can be helpful for troubleshooting. Eighthly, the UL listing. Look for a surge protector that is listed by Underwriters Laboratories, also known as UL. This indicates that the surge protector has been tested and meets safety standards. Ninthly, the warranty. Choose a surge protector with a good warranty. This will protect you in case the surge protector fails. When you are installing surge protectors, follow these tips. Firstly, install surge protectors at the point of entry. This will protect your entire electrical system from surges. Secondly, use surge protectors on all major appliances and electronic devices. This will protect these devices from damage. Thirdly, plug surge protectors directly into wall outlets. Do not use extension cords or power strips. Fourthly, replace surge protectors every 2 years. Surge protectors degrade over time and may not provide adequate protection after 2 years. To solve voltage surge issues, a multifaceted approach is essential, combining monitoring, source identification, and protective measures. Begin by deploying a power quality analyzer like the Fluke 1777 to capture detailed data on voltage fluctuations over an extended period. This will provide a clear picture of the frequency and magnitude of surge events. The data logs will show voltage spikes, dips, and other anomalies, confirming the presence and severity of power surges. Once the surge presence is verified, the next step is to pinpoint the source. Surges can originate from several sources, including the utility grid, internal wiring issues, or external factors such as nearby electrical equipment. Utility-caused surges often result from grid switching operations, equipment failures, or weather-related events. Contacting the utility company to report the issue can prompt an investigation of the power lines and substation equipment. They can assess the grid stability and make necessary adjustments to mitigate the surges. Internal wiring issues within the home can also cause surges. Loose connections, damaged insulation, or faulty wiring can create transient voltage spikes. A qualified electrician should inspect the electrical system, checking for any signs of wear or damage. Tightening connections, replacing worn wiring, and ensuring proper grounding can help eliminate internally generated surges. External factors, such as the operation of heavy machinery or electrical equipment in neighboring properties, can also contribute to voltage surges. Identifying and addressing these external sources may require coordination with neighbors or local businesses. After identifying potential surge sources, implement comprehensive surge protection measures. Surge protectors, also known as surge suppressors, are designed to divert excess voltage away from sensitive electronic devices, preventing damage. Install surge protectors on all major appliances, computers, televisions, and other valuable electronics. Choose surge protectors with a high joule rating, which indicates the amount of energy they can absorb before failing. For whole house surge protection, consider installing a surge suppressor at the electrical panel. This device protects the entire home from incoming surges, providing an additional layer of defense. A whole house surge suppressor intercepts surges entering through the main power line, preventing them from reaching individual circuits. Uninterruptible power supplies, known as UPS units, offer both backup power and surge protection for critical electronic devices. UPS units provide a temporary power source during outages, preventing data loss and equipment shutdowns. They also incorporate surge suppression circuitry to protect against voltage spikes. After implementing surge protection measures, continue monitoring voltage fluctuations to ensure the effectiveness of the solutions. The power quality analyzer can provide ongoing data to verify that the surge protection devices are functioning properly and that surge levels have been reduced. If new surges occur, repeat the troubleshooting steps to identify and address the underlying cause. Effective surge protection requires a combination of strategies, including using high-quality surge protectors, ensuring proper grounding, and avoiding overloading circuits. High-quality surge protectors are designed with robust components and advanced circuitry to provide reliable protection against voltage spikes. Choose surge protectors that meet industry standards and have a proven track record of performance. Proper grounding is essential for surge protection. A well-grounded electrical system provides a low-impedance path for surge currents to flow to ground, minimizing the voltage that reaches sensitive equipment. Ensure that all electrical outlets and appliances are properly grounded. Avoid overloading electrical circuits, as this can create voltage drops and increase the risk of surges. Distribute the load evenly across different circuits to prevent excessive current draw. Regularly inspect surge protectors for signs of wear or damage. Surge protectors have a limited lifespan and should be replaced periodically, typically every 2 to 3 years. Check the indicator lights on surge protectors to verify that they are functioning properly. If the indicator light is off, the surge protector may need to be replaced. In addition to the above measures, consider the following tips to minimize the risk of voltage surges. Firstly, turn off and unplug electronic devices during thunderstorms. Lightning strikes can generate powerful surges that can damage unprotected equipment. Secondly, avoid using power strips or extension cords to connect multiple devices to a single outlet. Power strips and extension cords can overload circuits and increase the risk of surges. Thirdly, use a dedicated circuit for sensitive electronic equipment. This will prevent interference from other devices on the same circuit. Fourthly, install a lightning rod system to protect your home from direct lightning strikes. A lightning rod system provides a safe path for lightning currents to flow to ground, preventing damage to the structure and its contents. Fifthly, consult with a qualified electrician to assess your home's electrical system and recommend appropriate surge protection measures. An electrician can identify potential surge hazards and provide customized solutions to protect your home and electronics. By taking these steps, you can minimize the risk of voltage surges and protect your home and electronics from damage. A proactive approach to surge protection is essential for ensuring the reliability and longevity of your electrical equipment. Remember to maintain and inspect your surge protection devices regularly to ensure they are functioning correctly. replace any damaged or outdated surge protectors to maintain a robust defense against voltage surges.